Good morning, welcome to a new tutorial video of Minero. This time we'll show the design tools of the software. In this exercise, we are going to generate the optimal fit for a face into McLaughlin block model. We proceed to show the block model. As you can see, it is set to show the gold grades of the model. We observe the color legend next to the values assigned to each of them. We notice the blocks in red represent the high gold grades, the blocks in green represent medium gold grades, and the blocks in blue represent the lower gold grades. The cursor is very small, so we are going to configure the cursor size. We must go to View menu and then select Settings. We change the cursor size from 10 to 50 and the inner cursor will be 25. We notice the bench height is set as 20 meters, which is very important. We'll talk about it later. In this moment, we are watching only the 1070 elevation in the status bar. The status bar is located in the lower part of the program window. Use arrow keys to go a bench up or a bench down. Bench up with up arrow key and bench down with down arrow key. Because the size of the bench is 20 meters, use arrow key to go down from elevation 1070 to elevation 1050. On table view under the info tab, we can see the information about the block model, such as its origin, its rotation, its cell size on the X, Y and Z axis, and the number of blocks. Now we are looking at the distribution of the gold grade in different benches. Remember, if you want to pan your design, you can use the scroll button. Turn off the block model. Now we turn on a design of a final pit which was created previously. This final pit will be cut by the topography. To do that, we have to use the loaded topography. Modify thickness up and thickness down values in render property. We input 1 million to display the object completely. Turn on the two objects. Use the Shift key plus scroll button to get a three-dimensional view. Go to the design menu and look for the cut and fill application or use Alt plus C keys. We are going to perform two operations. First, we are going to generate the instruction intersecting the topography with the design. Then we'll generate the final pit within the topography. In both cases, the topography would be input 1 and the final pit design would be input 2. The AND operator means intersection while NOT operator means subtraction. Two objects have been generated. One of them is the final pit extraction and the another is the ultimate topography. Also, we can have a three-dimensional view. You should change the color to see it better. In the same way, we proceed with the ultimate topography. We see both rounds. One of them is going to the east and the other has a switchback with direction north. The optimal pit application will be used to generate a pit shell for phase 1. A common practice is to decrease the metal price to generate a smaller pit and find the richest blocks of the model. In this case, the red blocks represent the higher grades. Recoveries parameters will also be reduced. A study was already done and it was found that optimal parameters to generate the phase 1 would be the following. In this window, the block model will be valued. The mining cost for waste and ore is $1 per ton. The processing cost for the ore is $4 per ton. The prices and the recoveries have been reduced. Two variables have been created: a numerical variable named value and a categorical variable named classification. In the value variable, we find the value of each block expressed in dollar per ton. In the classification variable, we find the classification of the block. It can be ore or waste. Then we will configure the block model to see which are blocks of ore and which are blocks of waste. We have to reconfigure the legend. We make the cursor smaller to be able to get a better view of the notation of each block and to see what values the compute value application gives us. The blue blocks are blocks of ore. The text is shown in red color. When a block is selected, its info is shown in the Contents tab. Now we proceed to generate the optimum count for phase 1 using the optimal path application of the optimization menu. We must load the block model with the value variable, which is the valuation variable, and the slope angle. The slope angle can be simple or can be based on a geomechanical row set. The pit shell is generated with the name of pit shell 1. Use key to create a new design. Configure the cursor to make it a little bigger. Display the topography to indicate where we should start the ramp of the open pit. We realize our design with ramp should start from the second bench because the first bench will not have a ramp because of operational constraints. Use E key to change to edit mode. To snap to any point of the pit shell, use Ctrl key. Use right click to erase a point. Use the R key to save the design. Now we will project this bench upwards, just one bench so it can intersect the topography. To do this, we will use the slope projection application from the design menu. This application also gives us the possibility of using our block model to use the domain variable to load a geomechanical row set, but in this case we will only use a simple angle of 45 slope. Use a key to add a ramp to the pit. As you can see, we have the possibility to load up to 4 ramps simultaneously and put their characteristics such as width and gradient to each one. But in this case we will only use one that will be the first ramp. To edit a line, first we must select it using Shift and left click and then use Ctrl key plus left click. Now we will project 5 benches down. We see that the pit is projected along with the ramp. We project 5 benches down again and see how it is going down the ramp. We turn on the pit shell to make the comparison with the design and we see there is not much difference. Because the minimum mining width at the bottom of the pit design, we won't be able to go lower. We use the cut and fill tools one more time, but this time we will intersect the design of phase 1 with the topography. We will generate the extraction and the face intersected with the topography and we will report it. As you can see in the grade tonnage report application, we have the possibility to load the specific variables that we want to see when we report grades and tonnage of the design. That was all for today. Thank you very much.